Now let's study the divisors of a number. We know that any given number n can always be factorized into its prime factors. So if we denote the prime factors as say p1, p2 and so on up to say pk, and each will occur a particular number of times. So let's denote their respective occurrences as nothing but the powers of their prime numbers. So if we denote the number n in this particular way, we are interested to know how many divisors are there of this particular number n. So to calculate that, let us rewrite this particular expression as, we know that this p1 raised to n1 is nothing but the prime number p1 is going to occur n1 times into the prime factor p2 is going to occur n2 number of times, and so on up to the last prime factor pk is going to occur for nk number of times. So therefore, if we want to count how many divisors are there of the original number n, basically we have to know how many ways are there to select any one or more of the individual prime factors from this particular product. So there is another way to visualize this particular thing, that is, if you think of a kind of flow diagram in which we have to travel from the leftmost point say A to the rightmost point B, and while traveling there we have to cover the particular prime factors. Now if we consider the first block, that is consisting of the prime factor p1, then we have to either consider 1, in which we are not considering the actual occurrence of the prime factor p1, or we may consider one occurrence of p1 or two occurrences of p1, that is p1 squared, and so on up to we may consider finally the all n1 occurrences of p1. So we have to travel through any one of these paths definitely, and so on for the next factor p2 till the last factor pk. So therefore, if you want to count how many divisors are there of the original number, it is equivalent to counting how many paths are there to travel from point A to B. So here we can see that in the particular first section we have n1 plus 1 paths. Similarly, for the second section we have n2 plus 1 paths, and so on till the for final section we have in all nk plus 1 paths. So therefore, we have total number of divisors of the original number is nothing but the multiplication of these particular figures, that is n1 plus 1 into n2 plus 1 and so on up to nk plus 1. Now of course this particular count also includes the two numbers, that is the number 1 and the original number n itself as the divisors. So if you don't want to include them and consider only what is called as the proper divisors, then we have to subtract 2 from the above answer. So the total number of proper divisors are given by the above product, that is n1 plus 1, n2 plus 1 and so on up to nk plus 1 minus 2. Now suppose we are also interested to know what is the sum of all the divisors of the number, that is sum of all divisors of the original number. Now if we consider the first block, basically it's a geometric progression of the first term as 1 and the common ratio as p1, and it goes up to p1 raised to n1. So therefore it will be nothing but the sum of this particular geometric series. So that turns out to p1 raised to n1 plus 1, because there are in all n1 plus 1 terms, minus 1 whole upon p1 minus 1, because p1 is the common ratio, multiplied by, for the second block we have similar structure, that is p2 raised to n2 plus 1 whole minus 1 and whole divided by p2 minus 1, and so on up to, we consider the last block, that is pk raised to nk plus 1 minus 1 whole upon pk minus 1. So that is the sum of all the possible divisors of the given number n.